Welcome to another month of the Diabetes Bio Podcast, a podcast for the Diabetes Journal, the flagship research publication of the American Diabetes Association. Each month, we will interview one or more authors from the feature articles, the papers of the month, or other articles published in that month's issue of the Diabetes Journal. But this month, we'll be doing an extended Sweet Talk segment, which Kevin is going to introduce us here in a second. And our Sweet Talk segment is more of an open format portion of the podcast that can include topical interviews or discussions, which is what we're going to do for the full hour today. My name is Darlene Sandoval, and I'm joined by my podcast co-host, Dr. Kirk Haberger and Dr. Kevin Williams. How are you all doing today?
Doing good. How are you, Dar?
Doing all right.
Kevin?
Doing great. Yeah.
I'm good. It's toasty here in Denver.
Oh, did it get above 80? Is that what we're talking about?
We've been in the mid-90s.
Okay.
We had a
fine.
little cool down on Saturday. I think it was in the high 80s, which was actually really nice. But
So, Dar, did you get a chance to enjoy the heat?
I did. I went out for a run.
Nice.
I just stuck around the neighborhood this weekend. I have a mountain run next weekend, so I was trying kind of tapering.
How long is the mountain run you got?
12
12
miles.
miles.
6
Nice.
miles up, 6 miles down.
What's worse, the up or down? Did we talk about this before? I don't know.
Uh, um, for me, it's actually the up.
The up is worse?
Yeah. I mean, the down wears on you after a while, but I'm pretty good downhiller and I'm pretty relaxed.
Yeah.
So I'm always excited to hit the downhill.
It's crazy y'all are in the 90s. Down here in Dallas, we're in 70s. We're at 76 right now, but it's rainy outside. So I think that's part of the reason. But yeah, it's crazy the inverse temperature there.
Yeah. So, usually when I feel like, on TV, there's always what's your favorite summer reading? But I thought I would ask y'all if you have a favorite science podcast. Of course, besides the Diabetes Bio podcast, is there one that you all enjoy?
Yeah, I have two. There was one I listened to all the time as a postdoc, especially when I was in the animal rooms, right? And you're just sort of have time to think or not think. And that was Radiolab.
Yeah,
I listened
that
to
was
that one
mine,
for
actually.
years. But now I've kind of switched over to a podcast called Science Versus. And
I've heard of that one.
my wife really likes that one as well. And so it's an easy thing to chat about.
Yeah, yeah. What about you, Kevin? Do you have one?
You know, I don't really have a specific science podcast that I've listened to regularly, but I do follow some science-y YouTubers. One in particular, his name's Destin Sandlin, and he runs a channel that's called Smarter Every Day. And I absolutely just love this channel. He has an amazing way of breaking down the really complex science-y engineering kind of concepts and making it engaging and really down to earth. And some of the episodes that he's talked about, which gets people's ears perking probably in interest, is talking about a backwards bicycle, Prince Rupert's drop. He talks about how space rockets work, and even talks about the history of film and specifically with photography. So it's one of those channels that always gets me excited, and it's something that you can just learn something new, and that's kind of the title of the channel of becoming smarter every day.
Yeah, cool.
How about you, Dar?
So I was gonna go with Radiolab because that's probably one of the original ones, and I definitely love it. But Hidden Brain is also a really cool one. If you haven't heard of that one, that's Shankar Vedantam.
Mm-hmm.
And I think he's probably done some Radiolab episodes. He might have actually, sort of branched out from Radiolab.
Yeah, that's another good one. I've hit that one up in the past.
Yeah. So we'd love to hear from our listeners. Tell us what science podcasts you like to listen to. Of course, the present one excluded. So you can engage with us on X, Blue Sky, LinkedIn. And so either respond to the ADA post or to one of our reposts and tell us what your favorite science podcast is. We'd love to hear from you. All right. So Kevin, why don't you tell us about our very special extended Sweet Talk episode?
That's right. Today, we're honored to be joined by Dr. Daniel Drucker and Dr. John Campbell. Dr. Drucker was the recipient of the Banting Medal from the American Diabetes Association in 2014, which is their highest scientific honor. And his groundbreaking research on incretin hormones, especially GLP-1, has fundamentally changed diabetes and obesity treatment worldwide. Dr. Campbell leads his own research program as an associate professor at Duke University, and he focuses on islet biology, incretin hormone signaling, and the metabolic mechanisms underlying diabetes and obesity. In the episode, we're first going to discuss the history of incretin biology research with Dr. Drucker. Then we discuss an exciting and really sometimes a controversial topic, the therapeutic targeting of the glucose-dependent insulinotropic polypeptide or GIP receptor. This is particularly relevant as in this month's issue of Diabetes, there's a special debate series featuring a point article which advocates for GIP receptor agonism and a counterpoint article supporting antagonism. Along with those articles, there's a perspective piece that's co-authored by Dr. Drucker and Dr. Campbell that really seeks to reconcile these differences in the views and frame the ongoing discussion. We should note that we did reach out to the authors of both the point and the counterpoint articles to join us in the same episode, but due to some scheduling and logistical constraints, they were not able to participate. But we're really thrilled to have Dr. Drucker and Dr. Campbell here to share their insights on this really fascinating and evolving field. And similar to Darlene, for interaction with the listeners, we'd really love to hear from you on about this episode. Do you think that GIP receptor agonism or antagonism holds the most promise for therapeutic strategies?
All right, excellent. Let's jump in.
Welcome to this special edition of Sweet Talk. I'm Kevin Williams, and today we're joined by Dr. Daniel Drucker and Dr. John Campbell. Dr. Drucker was the recipient of the Banting Medal from the American Diabetes Association in 2014, which is their highest scientific honor. His research on incretins, particularly glucagon-like peptide 1 or GLP-1, has not only changed the therapeutic landscape, but also deepened our understanding of metabolic health. Dr. Campbell did part of his training with Dr. Drucker and now leads his own research program as an associate professor at Duke University, continuing to advance the field in exciting new directions. I'm also joined by our co-host, Dr. Darlene Sandoval and Dr. Kirk Habegger. Dr. Drucker and Dr. Campbell, thank you for joining us today.
Pleasure to be here.
Let's go.
Today, we're going to explore Dr. Drucker's impact on the field, lessons learned from his career, the future of therapies and metabolic disease. But we're also going to be discussing a fascinating debate that's featured in articles published this month in Diabetes on glucose-dependent insulinotropic polypeptide or GIP receptors and the agonism versus antagonism of this pathway. This is a topic that both Dr. Drucker and Dr. Campbell contributed a perspective piece in this issue of Diabetes. Before we get into all that, we like to kick things off with a little bit of an icebreaker. And so I was curious, if you could solve one unanswered question in diabetes or obesity research today, what would that be? We'll start off with Dr. Drucker and then move on to Dr. Campbell.
I think the biggest opportunity for breakthroughs, as JDRF renamed itself, Breakthrough T1D, how do we safely scale up transplanted human islet beta cells without need for immunosuppression and really transform the world of type 1 diabetes? That I think it's not an area that I work in, but I have huge respect and share the excitement of the progress going on. That's the problem I'd like to see solved.
That's really great. Dr. Campbell?
It's funny that Dan went in that direction because I was instinctively going towards type 1 diabetes too. Maybe it just seems like it would be more amenable to immediate impact. But I am impacted by many people in my family and friends that have type 1 diabetes, probably one of the reasons I got into this in the first place. And so opportunities to understand how to identify and even prevent the disease would be something that I would be passionate about. Also something I don't work on either. So we have it in common.
Perfect.
All right, Dr. Drucker, I want you to take us back for a moment. You completed your medical training at the University of Toronto, then did an internship at Johns Hopkins, followed by residencies back in Toronto. At that point, you could have gone straight into practicing medicine full-time. but instead you decided to pursue a research career. First of all of us are grateful, but what took you to Mass General and Harvard, and why'd you decide to take that route?
Yeah, so my instinctive response is a plane, but I was very lucky that I had great mentors, and if I'm lucky, John might actually say the same thing, but we'll see how this rolls along. I was a trainee in medicine, a medical student. I thought it was really cool that these were professors walking around that see patients, that were teaching, that were doing research, a lot of variety, a lot of challenges. And I asked myself, how do you get to do this? This seems like a lot of fun. And the answer was, well, you have to become qualified. And part of the qualification for the research side of things was to learn how to do research. And I started doing that. Well, as a resident, I would scoot across the street and do thyroid cultures. And I went to slaughterhouses to get bovine thyroid glands that were available. I soon became the person that was allowed to take 10 millicuries of P32 to see if thyroglobulin was phosphorylated. I had no idea what radioactivity was and why everyone was watching me from the other room. So I was just very lucky. I was given opportunities to learn research. And then obviously this led to saying, okay, if I finish my clinical training, what do I do next? And the answer was, now you have to really formally pursue research training. And after a series of interviews, that's how I ended up at the Mass General.
Yeah, that's great. And I guess, for those aspiring scientists, and especially physician scientists, was there ever a point where you considered stepping away from research, where, maybe you decided this wasn't worth it?
Oh, 100%. I mean, maybe this morning was the last time, but no, research is difficult. Emotionally, a lot of experiments fail, your grants are rejected, your papers are rejected, you frequently don't get the support you think you deserve. And so, yeah, I when I was in Boston as a fellow, things weren't working initially, and I would, phone up the folks back in Toronto and say, "Do you think I could come back and be a clinical endocrinologist?" And then the next thing I heard was the dial tone. So this was a constant thought process. I don't think I'm the only one who questions whether or not this is the right thing or should I change trajectories. So I definitely frequently uh, entered the status of a despairing scientist and wondered if I'd made the right decision and maybe I should be doing other things, and maybe the rejections that I was getting was a sign that in fact, when I came back to Toronto, I interviewed with a bunch of the real PhD scientists, and several of them told me, "You're wasting your time. You shouldn't be doing research. You're an MD. You're not properly trained. You should just quit now before you waste more time." This has never left me. I don't think there's really a day or a week that goes by where I say, am I doing the right thing? Am I wasting people's time? Is this the best thing I should be doing with my life? It's just been a constant companion for me in my head.
Well, I can echo that. It may have been this morning that I decided whether or not this was the right path. So
Yeah.
So, Dr. Drucker, you started in the thyroid, but you made your way to the gut to studying gut hormones, GLP-1 and GIP. So, how did you go from the thyroid to the gut? What intrigued you about these incretins and their biology?
So honestly, I wasn't smart enough to be intrigued by the biology of the glucagon gene. I was interviewing at 3 labs that did thyroid research. I interviewed at the NIH with Bruce Weintraub, who cloned the TSH gene. I interviewed at Tufts with Seymour Reichland, who was the father of hypothalamic releasing hormones and was working on TRH. And when I interviewed it in Joel Abner's lab, he had a TSH glycoprotein hormone gene project. And so it was always thyroid focused. And as I said before, when I chose Joel Habner's lab, because it seemed to be the best environment for molecular biology at the time, and I got there and they said, sorry, Bill Chin is taking the thyroid project to the Brigham, so you work on the glucagon gene. And I won't describe to you the colorful adjectives. So this is probably a family podcast that went through my head. But, in those days, we just did what we were told.
Yeah.
And so I said, okay, well, never mind about the thyroid. I will work on the glucagon gene. Still came back to Toronto years later, entire practice focused on thyroid disease. My website, mythyroid.com, is still online. So this wasn't like a transient, I didn't ditch the thyroid, but
Yeah.
I was redirected in terms of research. Obviously, that's the best thing that ever happened to me, but shows you the, importance of serendipity and good fortune, right place, right time, etc.
Yeah. Yeah. And taking advantage of opportunities that come along.
Yeah, I think that's part of it, is that when you recognize someone's handed you an opportunity, go for it.
So in those early days as you were working on the glucagon gene, were there major challenges or skepticisms, like maybe, challenging dogma type of data that you were presenting that you encountered, and how did you deal with those?
So our initial focus, I worked a lot with a postdoc, Jacques Philippe, and collaborated with other people, including Al Powers, who many of you know. But our initial focus was to study, were the peptides made? How is the glucagon gene regulated? And it was not an easy system because there were no cell lines that were validated for secreting glucagon. Those actually came later. So the cell lines that we take for granted now, the RIN cell lines that make glucagon, or the alpha TC ones, those didn't exist when we started. And so it was difficult to do these experiments. And as you know very well, there are not a lot of cells in the gut that you can isolate and culture to study GLP-1 production. So we depended a lot on developing the models and trying to do the best job we can. And one of the things that I did with Jacques Philippe, we isolated, in fact, Jacques drove the isolation of the first glucagon producing cell line that you could then use to do a lot of these experiments. And back in those days, if you could put a gene into a cell and show that it made some hormones or that it had regulated transcriptional activity, you could get your paper reviewed at Nature. I mean, those were the early days of molecular biology. Obviously, today that would be supplementary figure 12B. But it was not easy in those days. We didn't have a lot of techniques. I think in 1986, I did my first PCR experiment. I had 3 water baths at 3 different temperatures and gloves. And I sat there for 2 hours and 45 minutes moving the rack from one water bath to one. So just to give you a sense, this was the early days of molecular biology. No kits, no fancy machines. You had to develop a lot of reagents and stuff yourself. So I'm showing my age now for everyone listening.
And mentioning websites, you also have glucagon.com, which I want to say I've used that as an incredible resource for myself for a number of years. So it's great to have those websites out there and available to scientists as well as the general public.
Yeah, I mean, this was also sort of an accident. I like technology, but I'm not very good at it. And I tried to get some of my oldest son's high school friends who were like the tech wizards. This would have been 1996, 1997. I said, can you build a website for me? And they said, yeah, sure. But then they never did. They were too busy. And so I actually went to the store and bought like Microsoft Front Page, which is like build a website for dummies, and perfect for me. And that's how I got started. And my websites are still unbelievably primitive. They're just sort of have a lot of information, but they're not very pretty or, fancy.
And one of the fascinating things that I think about with these incretin-based therapies, especially GLP-1 as it relates to the treatment of obesity, and correct me if I'm wrong, but they don't seem to have arisen from the way we think of the classical molecular genetics approach, where knocking out a gene in preclinical models causes obesity, and then researchers try to reverse that to induce weight loss and potentially develop future pharmacotherapies, in particular the GLP-1 receptor knockout mouse. It doesn't seem to be a major phenotype as it relates to changes in body weight, but pharmacologically, if you activate or drive that system, it can lead to pretty profound reductions in weight in both animals, preclinical animals, as well as in humans. And I'm curious what you think that tells us about how we should approach the development of future obesity or metabolic disease therapeutics. Are there any lessons we can learn from this, like agonism without that strong knockout phenotype strategy?
Yeah, you summarized this beautifully, because I think the message is don't put all your eggs in one basket. So it is great to have targets that stem from human genetics with an effect size and a direction that might be druggable. That's wonderful. It is great to see a really cool knockout phenotype and say, wow, I wonder if that loss of function phenotype or the opposite gain of function phenotype might be pharmacologically tractable. But you're 100% correct. You would never have developed GLP-1 or GLP-2 or GIP based therapies if that was your gold standard. Maybe GIP would be a little closer because the genetics there is a little supportive, and we'll get to that in the second part of this discussion. But GLP-1 was all pharmacology. So don't underestimate, the old sort of fashioned physiology pharmacology where we used to grind up animal extracts, purify them a little bit, inject them into animals, measure as much as we could and say, hey, I see some sort of activity here. And that's simplistically how the whole GLP-1 story unfolded. All pharmacology, as you point out, the physiology and loss of function is modest and would not have led to drug development.
It's funny. We often joke in my group that GLP-1 is a sort of a so-so hormone, but it's a really, really good drug target, right? And so I think that highlights your points that there's probably one or more of those still out there that where the physiology doesn't blow your hair back, but the pharmacology may.
Yeah, that's 100% true. People often ask me when I give lectures, what's like the true biological importance of why we have GLP-1? And they're very disappointed when I remind them there's no kids coming into the pediatric clinic with syndromic obesity or syndromic diabetes or syndromic heart disease because they have mutations in their GLP-1 pathway. It's just not important physiologically. In fact, unpublished observations, that we'll see soon, I think, if you're a human with loss of function of both alleles with the GLP-1 receptor, the presentation is seizures, not diabetes, not obesity, not metabolic phenotype, but there's a lot of GLP-1 receptors in the brain. And if you actually go back and look in, a paper in Nature Medicine we published with the Penn Group about more than 25 years ago, you can see that the knockout mice are more sensitive to seizure activity, and you can suppress seizure activity with GLP-1 medicines. And that's what humans present with. So you're very correct in saying for metabolism, the endogenous actions of GLP-1, I think, are like as a fine tuner and a little bit of a modifier, but not very critically important. Nothing like leptin or melanocortin or some of the other key signals that are absolutely essential for control of metabolism.
Dan, one of the most remarkable aspects of your work is the successful translation from basic hormone biology, as we just described, to widely used therapies. What do you think were the key factors that made that translation possible?
I'll probably annoy some people here and insult some people here, but what the heck? So we're big believers in reproducibility. And everyone listening to this will probably say, well, of course, so am I. So are we. We're all big believers in reproducibility. But in today's world of science, we don't incentivize reproducibility. We don't track it. We don't reward it. We don't generally call it out. In fact, we incentivize behaviors that lead sometimes to stray away from reproducibility, like the high impact, really novel findings in, highly respected journals that require almost a little bit of incredulity and say, really, is that possibly true? Could that possibly be how something works? And so I was brought up in science to do dose responses, time courses, multiple species. Reproducibility to me is not a baseball game that it only works 4 out of 7 times so you win the World Series. It pretty much has to work almost all the time for it to be true. I don't think every lab culture is like that, but you won't develop a drug unless you are laser focused on reproducibility.
So I think that leads to a great follow-up question that's a little bit more personal, but how does it feel to I mean, there are millions of people on GLP-1 receptor agonists. There are lots of GLP-1 targeted drugs in the pipeline that are benefiting patients. with either obesity or diabetes. So how does it feel to have that your work has had that kind of impact on patient care, right? Not just biological knowledge, but patient care.
So first of all, to paraphrase the ex-wife of a president, it does take a village. So it's not Dan Drucker that single-handedly built this field. There were many people working at the inception on the discovery angle. There have literally been thousands of people at multiple levels of the scientific ecosystem who have made this happen. So I think we all feel pretty excited about the clinical impact. And I never wake up without being aware that I have a very privileged sort of position to be doing science that makes a clinical impact. At the end of the day, I always self identify as a clinician scientist. I'm never far away from my medical school training. And literally I get emails pretty much every day from patients all around the world. And thankfully, most of them are positive emails. I do get the occasional, can you help me? Things aren't working out email. And it's just an amazing thing. And I was quoted, I think, a few days ago in a Spanish magazine where we did some interviews that, to me, improving one person's health is better than any 10 awards. That's just my personal viewpoint. If I can change one life and have some person regain quality in their life and diminish the health burdens that were challenging them, there's no award that's better than that. That's just how I feel. So it's an amazing feeling. It's only somewhat negative in the context that the demands, I think for all of us working in the GLP-1 field, the demands are enormous. There's such tremendous interest and we get asked to do so many things and there's only so much time in the day. So it's a privilege to have that problem, but it can be challenging, I think, for all of us in the GLP-1 field to meet the external demands and interests in the field. But it's a wonderful problem to have.
We're talking about GLP-1 based therapies, and obviously there's a lot that we've learned over the years from your work, from your colleagues, from your collaborators, from others in the field. But what do you think are some of the biggest knowledge gaps as it relates to GLP-1 biology that still needs to be answered?
So this could go on for a long time. But, so why do some people respond to GLP-1 and other people don't? Why do people keep some of the weight off when they stop GLP-1 and other people don't? Why do we lose 15, 20, 25% of our body weight, but then after 68, 72 weeks, we stop responding to the medicine? Why do we have this sort of response when the blood pressure is high, response when the body weight is high, response when the glucose is high, but then we tune down these receptor signaling mechanisms in very unique ways in all these different organs that I don't think is very well understood. And I think, the benefits that we're seeing in the liver and in the heart and in the blood vessels and in the brain and elsewhere, I don't think are well understood. I don't think they're just secondary to glucose control and to weight loss. I think they're profound other pathways that GLP-1 signals to that I think all of us here on this podcast are working on. So I think for young people starting in this field, there are dozens of new drugs that work differently that will have to be studied. There are major unanswered questions, both in the lab and in the clinic, that need answering. So it's almost like you're just starting to answer some of these really important questions. What a great opportunity for young people starting in science.
And as an extension on that, these have become very popular. There's a lot of hype, a lot of public knowledge about these drugs, and the media and general people know the name of these compounds. Have you been surprised by any misconceptions or public reactions to these drugs? Is there anything that you think scientists and clinicians about the way that they should approach public communication and the ethical use of these compounds?
Yeah, that's a lot of important questions rolled into one. So there still are tremendous misconceptions about the safety of GLP-1. So I hear every day, including an earlier conversation today, that the medicines just aren't safe and we don't know how safe they are and how could you take these medicines because they haven't been studied properly. So I don't think we universally do a good job in communicating the tremendous safety database we have for the class. Yes, every new drug and every new condition mandates that we start again when we study the safety, and we all continue to do that. But I think there's a big conception that the medicines are somehow horribly risky and will lead to all kinds of problems, and we should be very careful about even taking them. And so I think that's a big issue that I get almost every day. The public knows quite a bit. We also tend to, I think, assume the benefits of GLP-1 that are really not there yet, that are not really proven. Like there's a huge group of people in the longevity field who promote GLP-1 for aging, for health span. There are a lot of people who are healthy who do not live with type 2 diabetes or obesity or heart disease who are taking GLP-1 medicines because they believe that they don't want to wait the 5 or 10 years for robust evidence to emerge. There's the flip side of people thinking, well, GLP-1 is good for everything. It's going to cure everything. It's going to always reduce inflammation. It's always going to make you feel better. That's not true either. And so the lab gets a little discouraged when we have negative data, which we're very good at, as John Campbell will testify to. But I get excited. I say, look, GLP-1 didn't work for this severe inflammatory disorder. That's fantastic. And they look at me as I'm, what's wrong with you, Drucker? But I think it's really important to say GLP-1 does not work for everything. It does not always produce beneficial effects. Let's be thoughtful about the quality of the evidence and not overreach, because then you let people down and you disappoint people, and that's not good either. So there's tremendous misconceptions in multiple areas of GLP-1, and we could go on really, but I don't want to dwell on it too much.
So Dan, I want to take a little bit of a left turn here and talk about mentoring. You've mentored many young scientists throughout your career. What advice do you give, or do you find yourself giving most often to early career researchers?
I don't think I'm very good at giving advice, but what I transmit is, we're not very good at anything, right? So as if you want to read my grant reviews, you will see that written on paper numerous times. We're not beta cell experts. We're not neuroscientists. We're not cardiologists. We're not experts in anything. But I think what we're pretty good at is asking really relevant questions. And again, the audience is going to say, well, we all ask relevant questions too. And I think that's probably correct. But I think, my experience training as a physician and understanding human pathophysiology and disorders and unmet needs and really important questions that would be relevant clinically, that drives my narrowing down on the questions. Because we're very lucky as scientists. We have amazing technology. We can knock out any gene. We can overexpress any gene. We can manipulate any physiological systems. So how do you decide what to do? And for me, it comes down to like, okay, if I have these 5 potential projects and we work on them all, which answer would we be most excited about if we could answer one question, irrespective of whether the answer is, A or B or positive or negative? So I try and impart the importance of asking good questions. As simplistic as that sounds, I think that's what we focus on a lot in the lab. Like, what should we work on? What's the key question to be answered? What are people really interested in knowing? And, I think, as I said, that sounds so simplistic. Everyone would say we do that, but we really focus on that. In addition to the reproducibility, ask really good questions and make sure your experiments are robust in answering the questions.
And have you seen that mentorship evolve over the years, or has that sort of been the guiding light the whole time?
Every generation of scientists is very different. And I think it's more difficult to be a trainee now. There are more external pressures. Social media makes you aware of everyone else's successes and failures immediately. The humble brag is ubiquitous when you might not have something to, be excited about. So I'm more sympathetic to the current generation and the pressures that they're under. I think they are greater than the pressures people faced 5, 10, 15, 20 years ago. And so your style has to evolve to, encompass the emotional needs of trainees to a greater extent and not just the scientific mentoring and training.
So, among the many outstanding scientists you've mentored is Dr. Campbell, who is with us today. So, what was
I
it like
thought you were going to ask me to name them, and then I would say, I better mention Campbell.
So, what was it like having John in your lab? And was there anything that stood out to you when he was a young scientist? And embarrassing stories are absolutely encouraged.
So John was a very organized trainee. I think this was in part because of his skill set in being organized, but also he was married, he had a child, he had to get things done in a very systematic manner. He didn't have the luxury of, hanging around in the lab till 7 o'clock at night, 8 o'clock, 10 o'clock at night, etc. And so he would be one of the first people there and accomplish a tremendous amount per unit time spent in the lab. Very organized, very focused. There's an expression that the current president of the University of Pennsylvania, whose name is Larry Jameson, used to use in the lab when I was a postdoc with him, which was line them up and mow them down. So people in the South would use that. And I think John may not have thought that he, used that style, but John was very organized, set up the experiments, got the experiments done very efficiently. If there was a deficiency, which is hard for me to think of, but John may or may not contest this, John would often use words that were not really words or the correct words. And we would often have conversations in my office. They would say, well, let me teach you a new word that's actually correct for what you want to say. And I'd be interested to hear if John has a recollection of that or not. But that's a very minor point, but it became a little bit of a game between us.
Nice.
To that point, Dan, I had to look up what incredulity means.
Yeah, good. Yeah. I don't particularly have a very good vocabulary, but when you apply for medical school, you have to write these exams, like the medical college admission test, and they ask you randomly, like the meaning of like 50,000 words that you've never heard of. And I think that's, what made me read about all these crazy words. And also, I have had memorable rejection letters. The first time we sent a paper to Cell when I was in Joel Havner's lab, we got the paper back quickly. There was no email or fax in those days. It was just bad. And Ben Lewin wrote me, I have read your paper with interest. However, given the nature of the topic, I have decided to eschew this type of paper. And I didn't know whether to be like excited or depressed because I said to myself, what's eschew mean? And then I looked it up and it meant like to avoid or decline or, etc. So I too have had to learn, vocabulary as I progress through science.
Okay, we're going to bring John Campbell into the discussion here. So here's your chance, John. What drew you to Drucker's lab in the first place? Can you tell us a little bit about that experience and how it shaped your own scientific path?
This is where I get to return the favor and be embarrassing back. Okay, so maybe it would help for a little bit of context. I was in Toronto doing my graduate degree at the university about 10 miles north of the University of Toronto called York University. And as Dan had mentioned, I was married. We had a child. We had a second child on the way as I was looking for a postdoc. So, you start to do the Venn diagram of things that we need to check off. And one was stay in Toronto. I wanted to stay in metabolism. And then it was also shaped by my graduate experience. So I spent my graduate time studies looking at the effects of exercise on metabolism. And I was drawn to that because of my experience playing sports and being an athlete and just the general knowledge that exercise is good for you. Well, everybody knows exercise is good for you. So when you go to ADA and you stand there with an exercise poster, people go, that's cute. And they kind of walk by. And I think it really is important, but it's a field that you really have to stand out on to make people stand up and notice. So another sort of box I wanted to check was find a place where you could do impactful research. And as I was looking around the University of Toronto, obviously Dan's lab stood out, and we interacted and interviewed, and it went really well. And before either of us had sort of committed to the relationship, I went to a Keystone, and one of his senior postdocs, Ben Lamont, was at this Keystone. This was back when they actually had diabetes Keystones, and I went to go find him and said, "Hey, let me just connect with Ben, ask a few questions." Walked up to his poster, and there is a semicircle 3 deep around it, people trying to talk to him, and I was unable to get to Ben. And that was a moment where I decided this is the kind of research that I want to do. It's impactful, people care, it's done right. And that was the moment we decided to start off. And then moving forward, I sort of another story that got into it is I started my postdoc on July 1st. And I know that because the on July 2nd, my wife, who was with child, this our second child, went to the emergency room to start the labor. It was early, and I wrote Dan an email explaining the situation. And if anybody knows Dan, he responds to emails like text messages. They are instantaneously. If you don't get it back, it's probably because he's on a plane. Well, it just so happened that because this was a new account, there was some miscommunication. So he did respond back, but I never got the email. And so I spent the next 48 hours freaking out that this was off to a bad start. I'm not gonna, if you're not gonna show up for work, don't bother coming in at all, and all this. And it turned out it was just miscommunication. The email was fine. Take as much time as you want, and that's how it always was. But it helps dictate sort of the relationship that we've had since then. Helps explain why I've had to be so organized. It's funny that you brought that characteristic up. I don't consider myself an organized person, but necessity drives characteristics, I guess.
So I just want to highlight when I got to the Habner lab, uh, just starting labs, it was also July 1st. And I said, "Hi, it's not a holiday in the United States, obviously." And I said, "Hi, I'm Dan Drucker. I'm here from Canada. I'm the new fellow." And they went, "Oh, Joel didn't tell us you were coming. And he's away for the entire month of July. Why don't you come back in August?" So that was my in the Habner one. So
Nice. So we'll shift gears a little bit to talk about the GIP receptor agonism antagonism debate. And this has generated a lot of excitement and definitely some confusion in the field. And you both have co-authored a perspective piece in this month's issue of Diabetes that looks at this debate between the GIP receptor agonism and antagonism in the treatment of obesity. And it's inspired by two pieces. There are point counterpoint article series in this month's issue as well. Dr. Campbell, possibly could you help set the stage for our listeners? What is the history behind how targeting both GIP receptors with agonists or antagonists, how that was pursued?
That's a very long history. You probably need someone with more experience than me to answer that question. But I'll set the stage, and then Dan can fill in the blanks. I was actually recruited to Dan's lab to study GIP a long time ago, about 15, 16 years ago, I guess now. And at the time, we were knocking GIP out with this idea that the global GIP receptor knockout mouse and loss of function SNPs in humans, so the genetic data in humans, all pointed to loss of function gives a protective phenotype against diet-induced obesity. Nobody knew how or why or where. And so I joined the team with the mission of, well, where can you pinpoint this loss of function? An obvious target was the adipose tissue. The data coming out said that GIP promotes lipogenesis, causes the accumulation of lipid into fat, and logically that might be driving obesity. And so if you block that, you can prevent that. So there was a lot of preclinical data and human genetics data that would suggest that you would want to antagonize the GIP receptor. And there's been efforts along the way throughout the years that predated my joining this field and continuing throughout that to develop antagonists. None of them were very good antagonists. And so that field sort of burbled up and down and never really grabbed some traction. But ever since I got involved, all the way up until about 2018, it was antagonize, antagonize, antagonize. Now, 2018 is when tirzepatide comes out, and that sort of changes the rules. But really, if you want to see where agonism comes in, you got to go back to sort of 2010 when Richard DeMarchi and Matthias Trope were publishing some of the first multi-receptor agonists where you combine GIP agonism with GLP-1 receptor agonism. And that set off this long, confusing debate on everybody looking at antagonism or loss of function as the way to leverage GIP to target obesity, to now switching the rules and saying, well, maybe agonism is the way to go. And tirzepatide has been a really tangible example. Now, that came with some caveats because of the long-standing history that GIP could never be good for somebody with diabetes or type 2 diabetes or with obesity. It really caused some skepticism. And the initial reactions to tirzepatide, from my perspective, was there's no way it is a dual agonist. It's just a GLP-1 super agonist, and the GIP component is a cute feature, but not really a driving force. I think that the work has pursued afterwards has said, nope, looks like GIP is pretty important. And that continues to evolve as more and more data comes out showing novel aspects and important aspects for GIP agonism.
Yeah, so let's follow up on that a little bit. And can you walk us through the proposed mechanism by which either agonizing or antagonizing somehow gets us to a similar physiology?
So I can chip in. So this is a lot of fun because the science obviously opposes in many ways. And you say, how can you have opposing mechanisms producing such really cool phenotypes that are similar? And then you have the pharmaceutical industry that has to also place its bets on directionality. And those are not inexpensive bets. And you have tirzepatide, which is the best medicine ever developed for type 2 diabetes and obesity, leading the gain of function in the clinic argument. But then you have these emerging medicines that Amgen is developing, like Maritide, that say, you know what, maybe blocking GIP signaling has some clinical merit as well. And there are clearly neurons that respond to GIP and reduce food intake and produce weight loss. And we have a lot of animal data that supports that. And importantly, we've had pure GIP receptor agonists in the clinic, either in normal weight people or people with type 1 diabetes, or more recently, people that are a little overweight. And you give a pure GIP receptor agonist and you reduce your body weight. So there's no question that GIP can do that both in animals and humans. And there are neurons that transduce those signals, and those have been elegantly dissected in terms of whether they're GABAergic or glutamatergic, and many people have worked on this. But then, we also have compelling data, as John said, from human genetics, from animal genetics, from animal and human pharmacology, that when you block the GIP receptor or genetically attenuated signaling, you also promote weight loss. And the recent papers have suggested that this is because some of the GLP-1 receptor positive neurons are under tonic inhibition by GIP. And when you relieve that tonic inhibition, you sensitize either the endogenous GLP-1 receptor signaling activity, which explains the human genetics, or the pharmacological response to augmenting GLP-1 receptor signaling, which may explain why blocking GIP receptor together with activating the GLP-1 receptor produces such useful pharmacodynamic activity. So it's very confusing, but it's a lot of fun. I think we're making progress. We still don't have this whole story worked out. Why does the whole body knockout or the human genetic loss of function mutations, why does that dominate and produce a favorable cardiometabolic phenotype when we know that activating some of the GIP receptor circuits will produce weight loss? So clearly, there's still a lot to work out quantitatively and regionally and anatomically, but I think we're making a lot of progress, and it's a lot of fun. And kudos to Eli Lilly and kudos to Amgen for investing in proving that both strategies are really effective for people challenged with serious health disorders. So they deserve a lot of credit, because it would not be obvious going back 10 or 15 years ago which approach to pursue and what results one would obtain. But today we see that both strategies are very effective and likely to be very helpful to people, which is fantastic.
Yeah, I think that's really well put, and I'm still confused on why.
Well, I should not have
in all
gone first.
honesty.
I should have let John answer it.
No.
Crystallized it. Yeah, just to give you, in the article that John and I wrote together, which was a privilege, and thank you to the editors of Diabetes for organizing that. We have a figure where we try and explain how this works. And John will tell you, he will show you the battle scars, that it was not easy. It was not easy for us to get to this figure and try and simplify to the best we could how this all works. I'm not sure we succeeded, but it's complicated biology and it's still not fully worked out.
I think I have 17 versions and they all look very different. It was fun to watch it evolve. Fun in quotes.
And building on that, in that perspective piece, you both highlight many key questions that still remain unanswered. And what do you see as the most important studies or experiments needed next to possibly move this debate forward?
So let me take that. I'm going to take that from the medical perspective. And I think we did highlight towards the end of that perspective that we all focus initially on weight loss, and that's what drives our enthusiasm in the current frenzy for developing new and better and more effective weight loss medicines. But at the end of the day, there's much more to weight loss in terms of health. And, if we take a look and say, what's the most important unanswered question? So I am really looking forward to the outcome studies with tirzepatide. We have Surpass CVOT that will report in the next little while, in the next few weeks, I think, top line data for cardiovascular outcome data and safety in people with type 2 diabetes head to head against dulaglutide. And then we have Surmount MMO, a very important larger trial that will take a few years longer in people with overweight or obesity. And then we have Amgen in their phase 3 maritime program, where we'll get much more safety data, including a cardiovascular outcome trial. So at the end of the day, weight loss is what we focus on, and we seek approvals for weight loss indications. But if you're not improving human health and you're not safe, then the weight loss doesn't matter. So those are the sort of things that I think we need to see in the human trials. And we're going to start to see that data soon. First for tirzepatide, it'll take a little longer for maritime.
You touched on this a little bit in the first part of the interview, Dan, but there's heterogeneity in response to all weight loss interventions, right? Including even tirzepatide. And so looking forward, do you think that there is a possible room for both, antagonists versus agonists? Like maybe one might be better for a certain population of patients versus another?
Oh, 100%. I think this is a massive unmet need in the therapeutic field, which is to understand the heterogeneity. It would be wonderful at point of care to be able to take a drop of blood or a little bit of saliva, run it through an analysis, whether it's, genetic sequencing or biomarkers, metabolomics, whatever, and then say, oh, guess what? You're going to be a great responder to drug X. Let's start with that one versus let's just try and see how you do, and we'll figure out what's happening in 3 to 6 months, etc. And unfortunately, as we know, so far the world's best geneticists have not been able to demonstrate genetic variation with a meaningfully clinically significant effect size that will answer the question you're asking, Darlene. We've seen Novo Nordisk present pretty detailed proteomic analysis from the step 1 and step 2 trials, and they can determine the presence or absence of semaglutide, but they did not report whether or not the weight loss or other outcomes in those 2 trials was in any way related to the magnitude of the response of the proteomic biomarkers measured. And we've seen other people try and use metabolomics to answer this. So I think this is a very important problem because right now we're sort of old-fashioned trial and error. Let's try this for 3 to 6 months and see how you do. And there's nothing wrong with that if the drugs are safe, but the drugs are expensive. And if someone's not responding well, then we've wasted money, we've wasted time, and it would be wonderful to have a more scientific approach to tailoring therapy and more work to do there.
John, what about from a basic science perspective in terms of this whole idea that both agonism and antagonism are effective? Does it make you think about how you build your study design or research questions for your research program?
Absolutely. We have a large portion of our research portfolio dedicated to questions either directly related or somewhat related to what you just brought up. I think there is a lot of room for understanding how these drugs work. Our simplistic way of even just understanding how GPCRs signal is probably too simplistic. At least, from us dumb physiologists, we go, oh, here's a lock and key. If we can get this ligand to this receptor, we can turn on these cells and things happen. And the hardcore GPCR pharmacologists out there go, you guys have no idea what you're talking about. How you touch that receptor can have huge implications for how the cell responds. And that's a really simplistic single ligand, single receptor paradigm. Once you start to incorporate multiple receptors into the equation and multiple cell types, each with their own unique milieu and how they're going to react, then you incorporate agonism and antagonism, and the possibilities and permutations just continue to expand out farther. And that, with the heterogeneity that we've been discussing, says that for some of these drug combinations, they're going to be better for some people than others. I have no idea right now how to predict that, but it's an exciting avenue of research to pursue.
And one final question before we wrap up. Dr. Drucker, you've been recognized with many major honors throughout your career, and we mentioned the Banting Medal from the American Diabetes Association. I'm curious, what has the ADA meant to you over the years, both professionally and personally?
When I started going to meetings, we didn't go to the American Diabetes Association meeting because it was not clear that diabetes was the focus and disease that we needed to pay attention to. So we went to the basic science, endocrine society meetings where we were gratified to be submitting abstracts to the category called other, because even at that time, gut hormones and, it was just not on anyone's radar. But as we started to see the field move and there was interest in type 2 diabetes, then honestly, I went to the ADA meetings every year to learn, because I was not, I was a thyroid person. I'd be very skilled thyroid biology and clinical thyroidology, but I was a poseur in diabetes. And the ADA was like a great opportunity for me to learn both basic science diabetes and clinical diabetes, and meet people who knew a lot more than I did about diabetes. And, I'm not ashamed to say it. I had a lot of learning to do over the years to bring myself up to speed in all aspects of diabetes. And the ADA was a wonderful organization that provided journals that I could read that were very timely in terms of new research, and meetings that I could attend to learn a lot more. And so it's been very important to me in terms of my professional development.
Thank you, Dr. Drucker and Dr. Campbell, for joining us today and sharing your insights into incretin biology. And thank you to our listeners for tuning in to this episode of Sweet Talk. We also want to remind everyone that there are 3 articles in this month's issue of Diabetes focused on this topic. This special debate issue includes a point-counterpoint series exploring the benefits of either agonizing or antagonizing the GIP receptor, and a perspective piece by both Dr. Drucker and Dr. Campbell. I really encourage our listeners to check out these pieces. It's a fascinating subject and highlights where many current and future therapeutics are aimed. And before we go, I also want to spotlight a wonderful example of giving back to the scientific community by highlighting the Drucker Family Innovation Fund grants. This joint program between the Banting and Best Diabetes Center and the University Health Network Mount Sinai Hospital Department of Medicine is offering up to 4 grants of $75,000 each this year to support innovative research projects. You can learn more and apply at bbdc.org and click on the tab for funding opportunities. Dr. Drucker, would you like to add anything about that opportunity?
Discovery research is often risky and difficult to get funded. And this is just an opportunity to have people come with their really interesting, maybe off the beaten track ideas and say, hey, let's take a chance. Let's get some money going. Let's get some data and see where it goes.
Yeah, it's really a wonderful opportunity. And as always, don't forget to like, follow, and subscribe for more Diabetes Bio content.
Thanks to all of you for joining us on the Diabetes Bio podcast. We hope that you're enjoying our discussion of the work that the Diabetes Journal is publishing each month. The feature articles we discuss in each episode are freely accessible at diabetesjournal.org/diabetes and are also listed in the episode notes for your reference. As with any podcast, it really helps us if you like, rate, follow, and subscribe to the podcast. And if you have any feedback for us, we'd love to hear that as well. We look forward to presenting to you each month.